All right, so hopefully nobody had a heavy lunch. Well, I'll try to stay awake. So I'm from Kansas originally, and when I got into green infrastructure, it required me to take off my ruby red slippers and say, wow, climate change must be real, and we need to plan for resilience, and green infrastructure can be part of all these cool things. So, but anyway, I'd like to talk today about a stormwater infiltration project that was funded by a Proposition 84 grant through the State Water Resources Control Board in California. So Watearth is a water resources and green infrastructure firm. We do a lot of retrofits and also new developments with low impact development. We are a metro small business enterprise as well. I've got my email address up here for you. You're more than welcome to contact me if you have any follow-up questions, although I'm sure we'll also have time for Q&A. But I'd especially like to acknowledge this was a quasi-design build project where the design proceeded and progressed very quickly. The bid process preceded the design completion. We had a lot of critical teaming partners that I'd like to acknowledge. Chevron Energy Solutions, now Optera, was key in helping bring the project to successful completion. And they were involved because it included some solar arrays, and they helped the school district with financing and constructing that portion of the project. But our project goals, first and foremost, was to infiltrate 100% of the stormwater runoff. There were other goals as well with regards to improving water quality and also solving some existing flooding issues. There's a structure at the site that has flooded previously, so pulling in some additional elements. We also had a very aggressive schedule. The goal was to minimize the amount of time that the parking lot was out of service during the school year because it's very tight space-wise, and also it's an elementary school, so a lot of parent drop-off and pick-up. The project included pretty much from the grant phase all the way through construction phase. So very comprehensive and completed within a very short time frame. The low impact development features were very much focused on the parking lot, on the pavement, infiltration trenches, and then we were able to incorporate some vegetation for aesthetics and also to help block dust from some nearby open fields. So very, I'll show you graphically where it is in a minute, but out in rural Riverside County, which is east of here, a couple hours depending on traffic, maybe quite a bit longer than that. But there's not a whole lot of development around it. There's some population of about 6,000 in the town, and then quite a lot of agriculture and open fields. See the floodplain of the San Jacinto River, which is the watershed it drains to. And then there's quite a lot of topographic relief, not within the site itself, it's very flat, but nearby with the hilly mountain ranges. So the project was a little under 2 acres parking lot. The campus is a bit larger than that. And the goal was to infiltrate 100% of the stormwater runoff on an annual basis and also on a design storm basis, including an up to the 100-year 24-hour event, which is about 5.5 inches. Annual rainfall, 12 inches or so. And our soils were pretty cooperative, classified as, say, a type B, fairly well draining, with a hydraulic conductivity of about 1.2 inches per hour. So the existing parking lot was in a pretty bad shape of disrepair. And off to the left is the building that's had some repeated flooding. So grant assistance, typical items, graphics, preliminary technical memorandums, and so forth. But essentially, we proposed permeable pavement within the blue parking stalls with infiltration trenches on the end caps as an overflow. And it kept a fairly consistent parking pattern to what was there previously. And then the overflow, because we were anticipating we might not be able to grade everything to the porous asphalt or infiltration trenches. And if we have overflow and we're trying to infiltrate everything, it needs to go somewhere. So overflow is through a circuitous overland flow path into an existing infiltration basin and then onto a play field. The existing infiltration basin, we did not design this. This was under construction during our design process, but I'm standing in it to give you a scale reference. It appeared to have maybe about 3 or 4 feet of media in it. I'd almost call it more of a bioretention than infiltration, but for whatever reason they were calling it infiltration. I do want to point out there's no energy dissipation where the concrete conveyance path spills into the basin. So even like 9 months later, we're already seeing erosion and the water starting to find its own path. And then the play fields off to the back there. So hydrologic modeling was done in the EPA SWIM, and we looked at design storm events as well as about a 40-year period of record. And detailed processes were modeled, everything from the rainfall, the evaporation, surface storage, flow through, in this case a rock layer, as well as infiltration into the native subgrade. No underdrain on this particular project due to the existing soils. So our design storm results basically showed no runoff from the site in all of the events. In some of the events, there was a bit of runoff from the parking lot itself that was then dissipated by the infiltration basin and playfield. And we can look at the hydrographs of the runoff. So very minimal, about 1 CFS maximum. And again, that's from the parking lot, but then when it routes through the playfield, everything ends up being infiltrated. And then just graphically, what happens within the porous asphalt system. Basically, in the gravel layer beneath the porous asphalt, which I think was about 4 inches deep, that was about as minimal as we could go for structural reasons. We end up with about 3 inches of ponding, and then it drains through the existing soil pretty well. Similar performance with the infiltration trenches or basins on the parking lot. This graphic just shows historical precipitation on a daily basis. Now this isn't day 1, day 47, this is just the first rainfall event, the 47th and so forth. And then we can see the runoff that would occur from the redeveloped site in a similar rainfall pattern. So we are showing a little bit of runoff. Again, this is from the parking lot, and then it ends up routing through the playfield, but our maximum's less than half CFS. Then just summarizing rainfall events, how many create runoff from the parking lot, about 25 total from the parking lot, greater than 1/10 of a CFS, but 0 from the site. Our annual runoff of results from our continuous simulation modeling. So again, we've got the parking lot, which generates a little bit of surface runoff on the order of about 0.8 inches per year. But then once it routes through the playfield, we're down to 0 or minimal runoff from the site. So moving into the civil design components, basically we're working with quite a few existing constraints on the site. We've got grades at the existing adjacent streets, existing adjacent buildings, sidewalks, adjacent properties, bus maintenance area, and the client desired to preserve as much of the existing facility as possible. They didn't want to go in and start reconstructing sidewalks, which would require, just might not work with the doors that are in place. The ADA path was challenging with the porous asphalt. We also had solar arrays that had to be set elevation-wise before the design was complete. So once those were set, we were kind of stuck with these column elevations of where the pavement needed to be. And that's, we'll get to it a little bit later, but that's one of the challenges, I think, of the design build type project. We also had blowing dust not only from the open fields, but the bus maintenance area. The buses would tend to track in a lot of sediment, gravel, sand, and there's a lot of open area in it. So we incorporated some very small asphalt berms to try to block some of the dust. Here's a view of the completed parking lot, the solar arrays. There's porous asphalt under the solar. This is the berm I mentioned that's asphalt. So the idea of this is just to block some dust from getting into the parking lot, because realistically, it's very difficult, for school district to get out there too frequently with the vacuum sweeping. So we want to minimize the amount of times that they need to do that per year. We've also got so to give you a view of the maintenance area, we've also got a red curb in on the adjacent area, and that went back and forth several times, and ultimately we decided on curbing again, just so it's not a completely level surface, contributing more sediment. We also had to use larger rocks than normal in the infiltration basins. The maintenance supervisor brought up a valid point of, the small standard rocks, not great with small school kids. I do want to point out a construction issue on this. I think this is a beautiful project. It turned out really, really well. I think many parts in thanks to the on-site construction supervision by Chevron Optera. But one thing that they didn't send across my desk before it was completed was the infiltration trenches. So you can see the rocks come all the way up to the top of the curb. And really we want a little bit of surface storage in there. And I have not gone back and remodeled it, but I would suspect, because we weren't using much of the surface storage and there's still void spaces, I would suspect we'd see very similar results. But it does look a little bit different. Here's another area of pretty expansive path of porous asphalt on the parking stalls and lanes. So we just basically kept the fire lane as traditional asphalt. So all of the, some portions of traditional asphalt drain directly to the infiltration basins, some drain onto the porous asphalt, and then we've got overflows from portions of porous asphalt into the basins. All right, now the prettier part, the landscape design. So again, also several constraints. Of course, we wanted low water use given the site location. Also an idea of using California-friendly landscaping, which may include native plants, but also plants that are well adapted to the Mediterranean climate of winter rainfall and summer dryness. We also have constraints of being right up on the road right of way, being right in the parking lot, keeping trees away from the solar structures. So that was a little bit limiting in terms of what could be selected. And then apparently there's also a cold microclimate where they get some spikes of freezing temperature due to the open air and wind in the winter. So visibility concerns with the students. We also had some existing trees to be preserved. So again, a lot of dust expected from the open fields. And so this is a very gentle berm. I think we designed it to be maybe a couple feet tall with a flat top area and very gentle side slopes. So the plants aren't mature yet, obviously, but we've got the existing olive trees. There's also purple lantana, little John bottlebrush, prostrate rosemary, and western redbuds. So the western redbuds are native to the state, the other plants being well adapted, but again, all low water use. And the school district personnel were very specific and discarded several plants that were recommended. So we really had to collaborate to come up with a list that they were comfortable with, they knew the plants, and were comfortable maintaining. So we've got a educational element with interpretive signage geared towards the elementary students who also will have classroom curriculum as part of their science classes to do some monitoring. They did a really nice job of placing the mulch. Actually, they planted this extremely well, a lot better than some sites I've seen. All small plants, which is what we specified. From a water quality perspective, We're in a couple of impaired watersheds. We've got sediment, nutrients, as well as some other pollutants on the 303D list. So we're expecting, typical parking lot pollutants that we would see. And of course, the asphalt's already doing its job, or the porous asphalt of collecting pollutants. And the infiltration basins, these were supposed to have actually a depressed area to act as a sediment basin, which is really key in an area of high dust and sediment. So unfortunately, that's kind of a lesson learned from construction, but they are starting to accumulate and block some pollutants. So in a typical parking lot, we would expect, fairly extensive pollutant loads just based on standard EPA tables. But for this project, we're expecting 100% removal simply because we're not expecting any runoff except for in a very extreme event. The project also helps with hydromodification, management to receiving streams, because we've controlled not only the rate, but also the volume, the excess urban runoff volume. There was a monitoring plan that we developed. Tried to keep it very limited and reasonable, given that the district maintenance personnel were doing the monitoring. But it was basically a visual monitoring program of 5 to 10 events within the rainy season, just to confirm that everything's working. So we identified monitoring locations at overflow points, and then also along the porous asphalt edge. So the grades in the parking lot were a little bit challenging. We tried to keep the majority of the porous asphalt at 2% or lower. There were a few areas where it got a little bit steeper, just working with what was there. The Proposition 84 projects also require a project assessment and evaluation plan, PAEP. I won't go through the details on that, but it's kind of, here's what we're trying to do, here's our goal, here's how we're going to achieve it, and this is how we measure it. Maintenance, also a key factor for the long-term functionality. And so the maintenance plan was really geared at district staff. So there's a little bit of education in it, and then also a how-to and a what-to-do inspection list. And then just as a reminder, on our overview sign, we have a little bulleted list in the lower right-hand corner of typical maintenance items. Okay, so some challenges of the design build project. Again, very fast-paced, so it requires a lot of iterations and a lot of revisions, a lot of teamwork between the various consultants on the team. I mentioned the solar structures. Once those grades were set, that was hard-coded in because they actually started building the parking structure and solar arrays probably about 75% through the design. So once that was set, we were stuck, which made the ADA path, which was nearby, very challenging to meet, but fortunately we got there. The initial bids came in higher than what they had funds allocated for, even with the grant funding. So we went back through a value engineering process, and they rebid it, got a slightly lower bid, but the issue was, we lost a little bit of a factor of safety that had been built in. They did end up going with the lower bid on it through the value engineering process, but in my mind, I don't think that the value was there for the safety factor that was lost. It still performs fine, but we don't have excess capacity per se. And then on the construction phase, again, excellent. Chevron did a really good job, really good guys on the construction phase, but had a photo of the infiltration trenches come across my desk sooner. We would have been able to revise those. So as much as you can have somebody in the field that really knows what the facilities need to look like, that was very helpful. A few final thoughts. Low impact development can be an excellent tool to meet multiple objectives. This project provides improved aesthetics, water quality benefits, hydromodification management benefits, and solves existing flooding issues for the structures. The grants, I think, are really helpful for many communities, schools, other public agencies, just to be able to start using some of these techniques and to be able to fund them with their matching funds. And then in terms of outreach, the interpretive signs can be a very helpful addition. If you're interested in these topics, I've got a couple links for you for other presentations that I've done. I'd be happy to email them to you. And with that, I'll open it up for any questions. You're always welcome to stay in touch. Yes.
Can you explain the contracting angle of it a little bit more? Because it was a design-build project, and yet it was bid. Was it a best value contract?
Yeah, the process. So originally, Chevron Energy Solutions was working with the school district to put in the solar arrays and to help them with the financing and construction. And then the school district realized their parking lot was in horrible disrepair and they had all these other issues. So Chevron then retained the services of Grant Management Associates, a consulting firm, who brought us on board for the LID component. And we all went after a Proposition 84 grant, which was awarded for the project. But the award was to the school district, and then the school district kind of trickled it down through Chevron and the sub-consultants. Because it's a school project and